Good morning, my dear students. I'm happy to meet you all once again for a video presentation like this. In this particular video presentation, we'll discuss some problems which are very often tested in the board. Similar problems may be there. If you are lucky, the same problem may be there in your board examination. Just listen. The first problem goes like this. F minus 2 to 2, minus 2 comma 2, closed interval, 2, 0 comma 2 is defined as f of x is equal to root of 4 minus x square. Check for one-to-one onto nature of f. Let me just see how we go about it. Actually, normally what we'll do is I'll take f of x1 is equal to f of x2. If it implies u x1 is equal to x2 for any two x1, x2 in the domain of f, I mean to say the function is one-to-one. Normally that is how we say. Let me just take what happens, let us see. Here I mean to say root of 4 minus x1 square is equal to root of 4 minus x2 square. Taking square on both sides, 4 minus x1 square is equal to 4 minus x2 square. One second. It's not clear. It is 4 minus x2 square. After cancelling 4, I'll end up with minus x1 square is equal to minus x2 square, which will imply you x1 square is equal to x2 square, which will imply you x1 is equal to x plus or minus x2. Or I can just explain f of minus 2 is equal to root of 4 minus 4, which is 0. F of 2 is also root of 4 minus 4, that is also 0. Therefore, minus 2, 2, both have same image. Therefore, f is not one-to-one. I am having more than one element having the same image. Therefore, the function is not one-to-one. Okay, normally by range, I mean set of all values y or f of x takes is called the range. Now domain is closed interval minus 2 to x, therefore minus 2 less than or equal to less than or equal to 2. What are all the values x can take in general is called the domain. Now I mean to say, taking square on both sides, I'll get 0 less than or equal to x square less than or equal to 4. Then I mean to say 0 greater than or equal to minus x square greater than or equal to minus 4. Multiplication by a minus sign will interchange the inequality. Less than becomes greater than becomes less than, which will imply you minus 4 less than or equal to minus x square less than or equal to 0. Adding 4 on both 4 throughout, I end up with 0 less than or equal to 4 minus x square less than or equal to 4. Taking square root, 0 less than or equal to root of 4 minus x square less than or equal to 2. Therefore, 0 less than or equal to f of x less than or equal to 2. Therefore, range is equal to 0, comma 2 closed interval, which is the same as the codomain given here. Therefore, f is onto. If the range is equal to codomain, the function is said to be onto. Function is said to be onto, or another name for that is surjective. Another name for one-to-one is injective. Therefore, the function is onto but not one-to-one. Let me just repeat the whole process. F of x1 equal to f of x2, which will imply root of 4 minus x1 square root of 4 minus x2 square, which will imply 4 minus x1 square equal to 4 minus x2 square, which implies minus x1 square equal to minus x2 square, implies x1 square equal to x2 square, implies x1 equal to plus or minus x2. I am not getting x1 is equal to x2. If I get only x1 equal to x2, then only I will say f is 1. Well, this is one way of proving, or we can do any of the two methods. Both are not needed. F of minus 2, the image is 0. F of 2 is also 0. Now for minus 2, 2, both the elements in the domain has the same image 0 in the codomain. Okay, therefore f is not one-to-one. I am having two elements having the image. Okay, one-to-one means one element going to one element. Every element has only one element. I am not having more than one element having the same image. I am having so here, therefore it is not 1 to 1. Okay, your domain is minus 2 comma 2 closed interval. Now for x is lying between minus 2 and 2, taking square, x square is between 0 and 4. Multiplying minus sign changes the inequality. Now for minus 4 less than equal to minus x square less than equal to 0. Adding 4 throughout, I will get 0 less than equal to 4 minus x square less than equal to 4. Taking square root, 0 less than equal to root of 4 minus x square less than equal to 2. Now for f of x is lying between 0 to 2. Therefore my range is 0 to f of x of y lies between 0 and 2. That's the meaning of range. Range is nothing but is equal to the codomain. Range is equal to codomain. Therefore the function is onto. Therefore here the function becomes 1 to 1 but not onto. Function is only 1 to 1. It is not onto. I think it is clear. You are able to follow. I think you can just see the book also if you want. You can see the book also. I have written on the book. You can read the question if you want. You can read the question if you want. It's already done on the board anyway. Now, second question goes like this. Just listen. Show that sine inverse 5 by 13 plus sine inverse 3 by 5 is equal to tan inverse 56 by 33. That's what I am supposed to show. I'll just show you the question instead of writing on the board. Just see the question. This is the question. Just read the question. I'll show it to you just for a minute or so. Let me see the answer. I am not supposed to use the rule sine inverse x plus sine inverse y is sine inverse x root of 1 minus y square plus y root of 1 minus x square. It is not there in CBSE syllabus. Let me just see what happens. Let sine inverse 5 by 13 is equal to theta. Therefore, sine theta is equal to 5 by 13. I will take a right angle triangle in which one acute angle to be theta. Here opposite side will be 5k, hypotenuse will be 13k. See here, 5 by 13 is also 5 by 13. 50 by 130 is also 5 by 13. 5000 by 13,000 is also 5 by 13. Now I write a multiple of 5 here, multiple of 13 here. Now for the adjacent side here will be 13k the whole square minus 5k the whole square, which will get reduced to 12k. You can check for the calculation. From which I will get tan theta. Tan theta will be equal to 5k by 12k, which is 5 by 12. Now let me take sine inverse 3 by 5 is equal to 5. Therefore, sine 5 happens to be 3 by 5. Let me draw a right triangle in which one acute angle is 5. Now for opposite side is 3k, hypotenuse is 5k. Adjacent side now becomes 25k square minus 9k square is equal to 4k. Now therefore let me find tan 5, which is 3k by 4k, which is 3 by 4. Now let me try to simplify tan theta plus phi using tan a plus b formula. What do I get? Tan theta plus tan phi divided by 1 minus tan theta tan phi. I am using tan a plus b formula. This is reduced to 5 by 12 plus 3 by 4 divided by 1 minus 5 by 12 into 3 by 4. Let me just simplify. Taking LCM, 5 4s are 20, 3 12s are 36 divided by 48. This 48 goes up, divided by 48 minus, this is 15. This is 48 anyway gets cancelled. This is reduced to 56 by 33. Therefore, tan theta plus phi is equal to 56 by 33, which implies theta plus phi happens to be taking this to the other side. Tan inverse 56 by 33. Okay, therefore replace theta by sine inverse 5 by 13. Sine inverse 5 by 13. Replace phi by sine inverse 3 by 5. Sine inverse 3 by 5, which is anyways equal to tan inverse 56 by 33. This rule is meaningful whenever this product is less than 1. tan inverse x plus tan inverse y. The formula is meaningful when, of course, sorry, I am using only tan a plus b here. I am not bothered. I am not using tan inverse x plus tan inverse y. Sorry. I am using only tan a plus b formula. Anyway, let sin inverse 5 by 13 is theta. Sin theta is 5 by 13. Opposite side becomes pi k. Adjacent by 13k. By taking one of the acute angles in the right triangle is theta. Adjacent side now becomes 169k square minus 25k square is root of 144k square is reduced to 12k. Tan theta happens to be opposite side by adjacent side, so reduced to 5 by 12. Similarly here I'll get tan 5 gets reduced to 3 by 4 by taking sin inverse 3 by 5 is 5. Let me try to simplify tan theta plus 5. If the right hand side is in terms of tan inverse, try to find sin theta plus 5. If the right hand side is in terms of sin inverse, try to find sin theta plus pi here. The right hand side is in terms of cos inverse, try to find cos theta plus cos pi. Accordingly, I should find cos theta cos pi here. We'll be using in the formula anyway. Now for here it is tan theta plus tan phi, 1 minus tan theta tan phi. 5 by 12 plus 3 by 4 by 1 minus 5 by 12 into 3 by 4. Taking LCM, 20 plus 36 by 48 into 48 by 48 minus 15. Denominator I am taking LCM. And numerator also I am taking LCM. It's reduced to 56 by 33. For taking tan to the other side, theta plus phi gets reduced to tan inverse 56 by 33. For sin inverse 5 by 13 plus sin inverse 3 by 5 gets reduced to tan inverse 56 by 33. I want to minimize the videos for maximum 15 minutes. And for the rest we'll continue in the next video. Thank you students for patient watching. Rest we'll discuss in the next video. Thank you. There is a small correction. At the end of the first problem, the conclusion is given as f is 1 to 1 but not on to. Sorry, f is on to but not 1 to 1. Just see only that correction and then learn. Thank you.